All right, lesson 3 is multiplying radicals. The first thing that they're going to show you here in the book is a quick review of distribution, because we're going to be doing distribution with radicals. So we're going to do distribution with basically polynomials to begin. All right, so this is a bit of a review of the distributive law. I'll just jot it down over here on the top. If you have a multiplying a bracket with a binomial or a trinomial or anything in there that has multiple terms, the a has to scale every term. So you'd have a times b and you would have a times c. Any issues with that? You've seen that probably lots in your life at this point of the game. So this 4 has to distribute in. And what would be 4 times x? Well, 4x. And then 4 times 8. Oh, right. This feel pretty good? Okay, wait till you see the radicals. Okay, here we go. And when I draw these arrows, I like to write down the result as I draw the arrows because it sort of keeps me organized. So negative, and I like to also read it in my head. So negative 2x times positive 3x. Oh, a negative and a positive make a negative. And x times x is, of course, x. Good. I was waiting for someone. And then one more, negative 2x is going to scale a negative 5, so those double negatives will make a positive 10x. How you guys feel about that? Pretty good? Okay. So that is a monomial times a binomial. What happens when it's binomial? So off on the side here, let's just do it in general. A plus b times c plus d. You guys see this acronym over here, FOIL? FOIL. So that would be the first. What's the first? A times c. And then the O stands for the outer. And that would be A times D. So basically you put A onto both of them, the C and the D, and then you go, excuse me, you go inside, so that would be like inner. So that would be B times C, and then the last one, that's why they call it last for the L. FOIL, first, outer, inner, last. That would be BC and BD. So basically you can see that the A goes on C and D. Did you guys see that? The A goes on C and D. And what else do you notice? The B goes on C and D. Okay? But basically this is what you'd want. This one in the middle. That's the one you want. And then if you have like terms, you put them together. All right, so let's, do you need that still? Well, what do you guys think? Okay, so we have a 2x squared. And then we have 1x. Do you have to write the 1? So that's x being scaled onto the other 2. And then now you're going to put 6 onto the other 2. So you get a 12x and 6. Are you guys okay with what I just did there? 6 times 2x and 6 times 1. Am I done? Do you guys see any like terms? Okay, here's some like terms. So you get a 2x squared plus a 13x plus a 6. And you're done there. Okay, that's pretty much covered in Math 10. So I think you should be feeling okay about that. Yeah, I think most students, they do okay with the expanding. Do you remember being given these and having to factor into those? That's tougher, right? That's tougher. But luckily we're not doing that right now. Oh my gosh, look at this. I would just say, like, what's your plan of attack here? Times all of them by 5? Oh, very nice, Awil. First bracket only. Because if you put 5 into both, you're actually timesing by 25. Yeah, so only put the 5 into one. So you got a 10x minus 15. So the first bracket gets scaled by 5. And it doesn't matter which one you put in, but I think it would make sense to put it in the first one. Ultimately, it doesn't matter, as long as you only do it once. Yeah. To be honest, I would do the 5 last, but whatever. Okay, so now we gotta do the FOIL. So 10 by 4, we got a 40, and then what x do I put? X squared, because x times x is x squared. Good. And then we got a 10 by 7. That's a 70x. And then a 15 by 4. That's like 60. 30 by 2. 60. Is it positive or negative, this one? Good. Negative 60x. Whoa, that was a weird one. And then the last one, I don't know if I can do this in my head. 15 and 7. And is it positive or negative? Good. You checked yourself. Good. Negative 105. Excellent. Now, am I done? What do you notice about the 2 in the middle here? Good. So you have a 40x squared, 70 take away 60, positive 10x, and then we're going to take away 105. And that's the final answer. Feeling okay about that? All right, so basically we do the exact same thing, but we have to do it with radicals. Ozzy, you with us? All right. You still need that big guy? All right, I'll leave it there for a minute. You guys ready? Okay. We're not doing the investigation. Let's move on. Okay, multiplying radicals. Okay. At the top of this page, it says, to multiply radicals, the index must be the same. What did I say about the indices for this test? It's pretty much going to be all power. Oh, I said indices. That's plural for index. It's all going to be power 2 stuff. So it's all going to be squares. So you don't really have to worry about that first bullet. But those second bullets, do you see what it says? Radicand by radicand. And then I'll just jot that down for you on the side here. This is what it looks like. If you had a root b, and then you multiply that by c root d, what do you think goes together? A and the c, good, and then b and the d, good. That's what you're looking for. You put the numbers that are regular numbers, you put those together, and then you put the radicals, you put those together. It's kind of like you smush them together. You smush. A and C get smushed, B and D get smushed. You guys cool on that? So like let's do C, because it's exactly what I'm talking about. Back up. Right there. So let's do C right now because C is right here. So you'd put the 2 and the 4 together. Excellent. And then you would put the 5 and the 6 together as a root 30. And then, are you done? Could you simplify 30? Could you? Is there a perfect square factor that divides 30? What are the perfect squares? I'm going to write them on the board for you guys. Okay. Root 5 times root 2 is root 10. Now this middle one, very nice. I heard it back there. Very nice. 6 times 6 is, and then the square root of 36 is 6. So that one actually brings up a very interesting identity. Check this out. Square root x times square root x would be the square root of x squared. And the square root cancel each other, and you're left with x. So if you do a root times a root with the exact same thing inside, it's just the thing inside. Okay? All right, this one. Put the 5 and the 3 together, you get negative 15. And then you put the root 3 and the root 3 together for a root 9. And then what is root 9? 3. And then you just times those together and you get negative 45. If you practice this stuff, you guys, you have a really good chance of doing well on this exam, because there's really no, it's a lot of just skill practicing. So there's no, like, you know, proofs or whatever, right, that you've never seen before. Like, this is stuff that you can really practice at, get good at, and then do well on an exam. All right. So this one is a little bit weird. There's two approaches. The first approach is just to repeat the factor 2 times, because that's what a square means, is to just repeat the factor twice, power 2. And then you'd put the 4 and 4 together to get 16, and you put the 5 and 5 together to get root 25. But root 25 goes with 5, so this is really just 16 times 5, which is 80. So the other way is to put the power 2 onto both. You'd have a 4 squared and a root 5 squared. 4 squared is 16. Root 5 squared is just 5, and then you get to 80. So it's the same thing, no matter which way you look at it. So this is like the second column. This is like the exponent law way to do it. You put the power 2 on both factors, and then this is just a repeated multiplication way. And they're equivalent. Which ones do you guys prefer? Yeah, you know, the first one, like, a lot of people forget the exponent laws. That's why for the first column, like, don't make math harder than it is. You know what power 2 means. It repeated multiplication. Just repeat it. Numbers go together. Radicals go together. It's just multiplication. And don't forget to simplify. Okay. And this one here. A negative 7 by a negative 7 will give you a... Very nice. And then the 3 and the 7 here are going to give you a 21. And then can you simplify that? Does 21 divide by 4 or 9 or 16? It doesn't. 21 does not divide by 4. It does not divide by 9. And then 16 is too big. And yeah. So that's as simple as it gets. Okay. So we did the first one on the board already. I really don't like that they put an x there, but it's root x, which is just, I'll do one intermediate step just to show you that it's just x. I don't know why they did. I know they don't ever use it, but they did that time. It's really bizarre. Yeah, the one time you don't want to use it, they used it. Yeah, it's interesting. So anyways, it's just root x. Put them together, you get root x squared, and then the square root and the square, they cancel each other. So for this next one, I wonder if you could do this quickly. 8 by 9 is 72, and root A is just, careful, is just A. Because what is root A? That's root A squared, and the root and the A squared, I'll do it on the whiteboard. Too much words. It's exactly the same thing. Root A is root A squared, which is just A. Same stuff, right? Oh, Olivia, do you mind just taking your headphones off, please, and joining us? Thank you. Now this one would be 2 by 5 is 10. And now because it's not root x, you can't just go to x. It's root x, root y. So you can't like cancel anything because it doesn't go to a square. So it's just 10 root xy. All right. Michaela and Richard are determining the radical product. Michaela multiplies the coefficients and multiplies the radicands and then converts into a simpler mixed radical form. Show her method. Okay, so put the 2 and the 5 together, you get 10. You put the 8 and the 12 together, you get, what is that, 96? Is that right? Thank you, sir. Now she wants to go into the simple form. So now I got to think, okay, what divides 96? So that's when you grab your calculator. Everybody's trying this. This is something everybody's got to get good at. 96 divided by 4, 96 divided by 9, 96 divided by 16, and then see which one's the best one. 32 is not an option. $16 works, hey? And then you're left with 6. Beautiful. So you go root 16 and root 6. And then what does the root 16 become? Good, a 4. And then what does the 10 and 4 together make? 40. So here's the final deal. Now Richard, he's a bit of a know-it-all. You know, that kind of guy, you know. Richard here. He is actually going to convert them into simple mixed radicals first and then multiply. I wonder how he could do such a thing. Let's check it out. What if we just simplified the root 8 first? What would that be? Which one divides 8? I mean, it's pretty obvious. Which is, forget 4 and 2. And then what does that 4 become? So you have 2 times the root of 2, and all that will make what? 4 root 2, okay? So that's the first one. Now do the 5 root 12. This one's also nice and easy because 12, I mean, the only option is 4 and 3, good. And then what does that 4 become? 2. And then 5 times 2 makes, that's a 10 root 3. So now those two answers in the circles, put those together. 4 root 2 times 10 root 3, and you get 10 by 4 is 40, and 2 by 3 is 6. See how you get to the same result? Which one do you like better? First one had less work, but a higher number. So you got to be confident that you're able to find the right number. Second one had more work, but had lower numbers, so it's easier to find the square that works. So you got to pick your enemy on that one. They will both always work in all situations. Look what the stop note says. It's usually easier to convert to simplest mixed form before multiplying, especially if the radicands are large. Okay? This one's on your quiz today. You're just given a rectangle, but the length and the width are given as radicals. So what is the area of a rectangle formula? Length times width. So you have 4 root 28 multiplied by 3 root 25. So here's what they're talking about. Put 28 and 25 together. 28, not with addition, with multiplication. 28 and 25 makes 700. That one's actually an easy one because it's a factor of 100. But, like, could you just simplify this before you just start multiplying? Like, what would the 28 make? Which one of those divides 28? 7 and 4, right? So put the 4 first and then the 7. Now I'm not going to do anything with this 3 yet. What is root 25? Yeah. So we can make it way easier. You guys see that? And I know if the times tables isn't there for you, you might not know that 28 is 4 by 7. So you're going to have to be quick on your calculator. Okay, 28 divided by 4, oh, it worked. And 7 is prime, so that's as low as it goes. So now you want to put all the numbers together. So, but first I'm just going to clean one of them up. All right, a little bit messy here. So that's a 4. What's this one? Root 4 would become 2. Then I'll put the 3 next to it, and then I'll put the 5 next to it, and I'll put the 7 off to the side. And then you just put all the numbers together. 4 times 2 times 3 times 5. 15 times 8. Can't do it in my head, I suck. 120? That's the final answer I got. 120 root 7. Okay, let's do it the other way. Okay, so let's do it over here. So well, you'd put the 4 and the 3 together, right? That gives you a 12. And then you put the 28 and the 25 together, which we said was 700. 700's an easy one, so I don't want you to feel like this is an easier way to do it, because if it's a more ridiculous number, it might be harder. What's the square of 100? 10. So then it's 12 times 10, 120 root 7. So same thing, right? No matter which way you look at it. All right, Kyler? You can hear Leighton? That guy. Okay, as long as you come back quick. Yes. Okay. Remember we practiced the distributive law at the beginning of class? Okay, now here's where it comes into play. I know, right? Okay, first one. What does that root 7 have to do? Yep. And then it also has to go on to the outside. Good. So it goes on to both, right, Harley? So 7 and 3 makes, and 7 and 2 makes. And then if you do this on the test, I'm going to be very upset. Do not put 21 and 14 like that together. That's a big no-no. That's a big no-no. You do not just add them. Remember, that's what we've been talking about for the past couple days. You have to break them down. Unfortunately, these ones don't break down. So this right here, ladies and gentlemen, is the final answer. That's it. You do not add them. That's what we talked about yesterday. What do they need to be added? They have to have the same radicand. It's like terms. You cannot add those because they're not like terms. And do you go to a decimal? Good, I will. You guys listening, I like it. Okay, let's jump into here. You guys are growing. You guys are growing. Hey, Knack. Check it out, man. Hey. Oh, yeah, nice water bottle, man. Oh, yeah, oh, yeah, oh, yeah. Okay, this one's a bit weird. Okay, do you remember how I say the numbers go together and the radicals go together? What's the number here that's not written? A 1. Okay, very good. Uno. So -1 times +2, -2. And then the 6 and the 3 combine for 18. Are we done? You gotta do the other one, all right? Now this one is a bit dicey. Be careful on this one, because what's the coefficient on both of these? -1 and a -1. Good. So you get a positive. Do you have to write the 1? No. You can. You definitely can to help you. And then what's 6 times 2? 12. So now these two, can I just add them willy-nilly? Ooh, this guy's clever. He's seeing beyond. On the last one, it was at 21 and what? And those don't divide by any of these. But these ones do. 18 divides by, and 12 divides by 4. So these can be simplified. Okay, so the 18 becomes √9 √2. And the 12 becomes √4 and √3. And if you look at my structure, I always put the perfect squares first because it'll be easier for your brains to collect the coefficients on the left. And then the other thing is, you know, look where my plus sign is, right aligned above it. Stay organized, folks. All right. So -2, that's a 3, √2, plus that's a 2, and that's a √3. So altogether you get -6 √2 plus 2 √3. Final answer. Why is it the final answer? Because you cannot add terms that are unlike. √2s do not go with √3s. They actually don't like to mix. They don't like to mingle. 2s don't really like 3s. All right, that looks good to me. Ooh, this one looks very fun. This goes on there, and you get 2 √x √x I just wrote it twice. And then this one goes on and you get root x, root y. Any issues with that? You're just putting a factor onto each term. And we've done this one before, root x, root x. What is that one? Root x is just? So we've talked about this one already. That becomes just x. And then those guys, they combine, but you really can't do much with it. You just put xy. Good. Final answer. All right, now we get to some fun. Have you guys ever had so much fun? Area of a rectangle, Mr. Ryan Proto, is... Oh, you're a good man. You're a good man. I am good. Go with it. Mr. Length and Mr. Width, those go together for a product and you get area. The length is, what's the length? 4 plus root 6. And what's the width? 7 minus root 6. This doesn't look very beautiful. This looks frightening. Why is this frightening? Because you have to do this. It's easy? I love it. It's easy, you guys. We can do this. 4 by 7. We can do this. 4 by 7. 28. And then 4 by a negative root 6. So is the 4 a regular old number? So which one does it go with? The negative 1 or the 6? Good. So it's 4 times a negative 1. Good. Negative 4 root 6. Now when you come inside, you go root 6 by 7. How does that go? You have, careful, put which one goes in the front though? So you have 7 of the root 6's. And they're positive. You have 7 root 6's. And then the last one. There's a couple cool things going on with this last one. You have a positive times a negative. Kind of, yeah. Do you mean the radical? So first of all, positive times a negative, so this term is negative. And then root 6 and root 6 is just like this. Yeah, it's just 6. Could you go here? You could, right? 6 times 6 is 36. If you forget that, like during the test, could you just go 6 times 6 is 36? Yeah, and then as long as you simplify that after, you're good. Now, what's the only thing that might mess you up in the middle here? So 28. What's negative 4 plus a 7? You have negative 4 root 6's plus 7 root 6's. How many root 6's you got altogether? 3 root 6's. That's the stuff from yesterday. The 3 root 6. So this is no different that if this was like minus 4x. Here, I'll write it for you so you see it. The middle stuff, Aussie, is like negative 4x plus 7x, 3x. It's the exact same idea. It's just like terms. And then the square root of 36 is 6. Now look at this. You still have some more like terms. What's 28 take away 6? Positive 22. So that's the final answer. Lots of like terms in that one. When Olivia gets back. Okay, just gonna do a quick little calculator demo. Okay, what I'm about to show you is a possibility for cheating on multiple choices. Guys. Oh, jeez. Okay, so that was the original question, right? And then this is the one of the options in the ABCDs. Oh. So that was the question. And you get 29 point all this crap, right? So then you have all these options, A, B, C, and D, right? Could you not test every single one of them to see if they match up? Okay, so you might be able to cheat in the multiple choice, but just remember that most of the exam will be written. So probably about half of the exam will be written. So if you don't commit to learning this properly, you won't pass. Like, the other thing is, like, this could be a check. This is like, rather than thinking of it as like, oh, I can be better than the test, multiple choice, I can beat the multiple choice. Think about it as like, oh, I could double check my answer. Did I do it properly? So I just typed in the first one as I saw it and the final answer as I saw it, and then matched up the values. There. Okay. We only have one more, Abel, and then I'll leave it up for you. Okay, let's check out the last one. I believe it's the last one. Is it the last one? Yes, it is. Okay, let's do the last one. So this one's actually not a see, this one's a rectangle, the one beside it. Why is this one a rectangle? Because the length and the width are different. Here's a square, the length and the width are the same. Now, on the exam, they might give it to you like this. 2 root 18 minus root 27 squared. You know, they might try to trick you a bit. It's a bit of a trick because what students want to do is they just want to square that one and be done. But you can't do that, right? You have to distribute so you have a middle term. So you have to, if you see something like this, I would write it out twice just to be on the safe side. Okay, so you're going to have to FOIL. So, does anybody see a problem that's about to show up? Well, like 18 times 18, like, it's going to be big numbers. And 27 times 27, 720. Maybe could we simplify this first? So let's simplify it first. Okay. So this is a 2, and the 18 becomes root 9 root 2. 27 becomes root 9 root 3. Close the bracket, that's the first one. And then it just repeats itself. It's the exact same, right? Root 9, root 2, and root 9, root 3. It just repeats itself. And then I'm going to simplify. What is this value, root 9? It's actually a 3, right? So 2 times 3 is 6 root 2. And what's this value here? That's just, root 9 is just 3. Good. So you have 3 root 3. And then because it's the exact same term, you can repeat it. Now I just feel a little bit more confident with this one because the numbers are much smaller. And all I had to do was just a quick simplification on some smaller numbers that'll probably be factored by these smaller numbers 4 and 9. Rather than going to some massive numbers that might have some weird squares that I might not recognize. Okay, so the first 6 times 6, root 2 times root 2, root 4. Root 4 is just good. See root 2, root 2? That's no different than this one. Root x is just. Could you go to root 4? Yes, as long as you remember that root 4 is exactly 2. And now here, oh my gosh, it's a positive times a negative, so this whole term will be negative. And then 6 times 3 gives 18. And then root 2 and root 3 make root 2 by 3 is 6. You're timesing. Okay, now go on the inside. A negative 3 and a positive 6, it is the same thing because it's a square. And then on the last, got to be careful on the last because you have a negative by negative. So you have positive 9. And then what's root 3, root 3? Root 9, which is just 3. Now what do you see in the middle? And what do you see on the ends? So 36 times 2 is 72. That's this one, right? And what's 9 times 3? 27. So those go together. And then on the inside, 18 and 18, those go together for... No, it's not timesing. Because it's minus 18 minus 18. So it's minus how much? Yeah, minus 36. So if you're stuck on those, like you can use this. Negative 18 plus negative 18 gives negative 30. You just add the coefficients without attaching the radicals to the calculator. And then 32 and 27 was at 99? Wayne Gretzky. 99 minus 36 root 6. What a beast of a question, hey? Okay, so why don't you guys practice for 15 minutes and then I'll give you a quiz. Oh yeah, baby.